So in this video, I'll be briefly talking about dplyr. For this exercise, I'm going to be using RStudio, and we'll be using the tidyverse package. The slides that I'm using today are available at this link here, but I'll also make those links available in the video description. I'd also like to note that this particular exercise is going to be a very quick intro into what dplyr is and the basic ideas of it, but there's a lot more that you can learn about dplyr, and I highly recommend a bunch of free resources out there. I'll also add those to the video description, and there are a couple links at the end of these slides. dplyr is a package that provides this framework for wrangling data, and in R that's mostly going to be data frames. dplyr is also part of this bigger tidyverse, so if you load tidyverse, dplyr is also loaded. You can also install dplyr as a standalone package if you'd like to. So instead of installing the entire tidyverse, you could just install dplyr with these commands. I'm assuming that you already are somewhat familiar with R, but just to recap, data frames are this primary representation of data inside of R, and it's useful to just think of these as two-dimensional tables of data. And for me, it's always helpful to think of these data frames as this table where each column is representing some variable or a feature that I'm interested in, and each row representing some kind of observation. For this exercise, I'm going to use a preloaded data frame called diamonds. It's loaded with tidyverse. About 54,000 rows of diamonds, various diamonds. It has the price, the size in carats, and the cut, color, clarity, and some dimensions related to each diamond. You can see more about it by running this $diamonds in your R command line, and that should pull up the documentation. Now, in order to use dplyr, it's useful to understand the concept of verbs. So a verb in the world of dplyr is simply a function that will take a data frame as its first argument, and as a result, it'll return another data frame. For example, the head function that's in base R can be considered a verb, because if you give a data frame as a first argument in head, then what you get as a result of that function is another data frame. In this particular case, you would get a data frame with 3 rows. And one of the core ideas of dplyr and the framework of dplyr is that most of all the data manipulation tasks that you face can be satisfied with about 5 basic verbs. And those 5 are, first, selecting a subset of rows that meet some condition. For example, say you want to get all the boys out of your student data. That would be subsetting by rows. Or you could subset your data by columns. For example, if you had the student score data, say you just want the names and scores, that would be subsetting by columns. Another verb would be to create new columns, and this is usually by combining existing columns. The next task would be to sort or reorder, or in dplyr's case, arrange the data by certain criteria. For example, if you want to rank your students by the lowest to highest scores. And finally, the 5th verb is to summarize. It's aggregating values into a single value. And we'll take a closer look at each of these verbs. So first, selecting rows. The verb in dplyr for selecting rows is called filter, and like I said, this lets you select a subset of rows that meet certain criteria. So here I have RStudio, and I'm going to load tidyverse. And let's just quickly take a look at the diamonds dataset. So if you run that, you see it has this caret, a column of cut, color, clarity, and these dimensions. Now let's say I want to find the diamonds where the cut is ideal and that are larger than 3 carats. Then I would use the filter, and the first argument is my data frame, so I'm going to use diamonds. And now I specify my conditions. So if I want the cut equal to ideal, and I want diamonds that are larger than 3 carats. And if I run that line of code, then I get this reduced or subsetted data frame that meet this criteria. You can specify OR conditions. For example, if I wanted all diamonds that were less than, say, 0.2 carats but greater than 3 carats, I should write diamonds carat less than or equal to 0.2, and OR, like in most computer languages, is specified by this bar, or the carat is greater than or equal to 3. And if I run this line, I'll again get the subsetted data frame of diamonds that are less than or equal to 0.2 carats or greater than or equal to 3 carats. I could also mix and match various conditions. So for example, if I wanted diamonds that were less than or equal to 0.2 carats or greater than 3 carats, like before, but now I also want to restrict to diamonds that have color D. Then I say color equals D, and by default, the behavior of filter is to use an AND condition if you specify multiple conditions by a comma. And here again we have all the diamonds that meet these 3 criteria. So that's filter and selecting by rows. One of the wrappers around filter is slice, and this is for those cases when you want to select the rows of your data frame, but by numerical indexes rather than some condition. So for example, if you want the first 10 rows of diamonds, however it's sorted, then you'd use slice diamonds 1 to 10, and you'd get those first 10 rows. Some of you who are familiar with R might think, oh, why couldn't I just do diamonds and then index it with the square braces? And yes, that works very well too. But again, this expression isn't a verb, whereas the slice is a verb in the sense that it takes the first argument as a data frame, and the result is also a data frame. Also, there are some special functions that dplyr provides, and one of them that's used often is the n function. And this n function, if used within a verb, will give you the number of rows within that data frame. So for example, if we wanted to use slice to get the last 10 rows of diamonds, we would say slice, again diamonds, then we create this numerical vector of n minus 9 to n, and that would give us the last 10 rows of the diamonds data frame. Now the second verb is select, and that is for selecting columns as opposed to rows. For example, if you wanted to select just the cut and price columns of the diamonds data frame, you would use select diamonds cut and price. And that would give you these 2 columns. You can also use negative indices to specify which columns to drop. So for example, if I just want to drop the x, y, z columns from my diamonds data frame, I would do minus x, minus y, and minus z. And if I run that, again I get this data frame with those 3 columns dropped. Select comes with some helpful functions. A more detailed list of those functions you can get from the documentation of select. But for example, you can use starts with to match columns whose names start with a certain character. For example, if I wanted to select, for some reason, all the columns that start with a C, I can do select from diamonds, starts with, and then provide a character C. Then I would get all these columns that start with a C. And some other helpful functions are ends with, or contains, or matches. The third verb is mutate, and that's for creating new columns, usually from existing columns. So, for example, if we wanted to create a price per carat, which is simply the price divided by carat for each diamond, then we would do mutate diamonds, and price per carat equals price divided by carat. And if we run that line, you can see that we have price per carat now. Now say we wanted to compute some estimation of the volume of each diamond, which is simply the x dimension multiplied by the y dimension multiplied by the z dimension. To do that, we can just compute volume equals x times y times z, and that would add this other column called volume. And one of the neat things about mutate is that you can use a column that you've just created inside the same mutate call to create more columns. For example, if we now want to compute the price per volume, we just add this new mutate command here within the same mutate function call. We can reuse the volume. So we now do price divided by volume. And mutate sort of internally figures out all these columns, which is really nice. There are some cases where we want to create new columns, but only keep those created columns. For example, if we wanted to create the price per carat and have a new data frame that only contains the price per carat, then the verb for that is transmute. So if I do this, then I create this price per carat column, and the result is just the single column data frame. The next verb is for sorting, and the name of that verb is arrange. And the default behavior of arrange is to sort in ascending order. So if I were to arrange diamonds by price, then that would give me all the diamonds by the lower prices first, so in ascending order. If I wanted to get the highest prices first, then I can specify the descending order by using the desc function. So wrapping the price in the DSC, desc function, tells arrange to arrange the diamonds data frame by descending order of price. Now we have the most expensive diamonds first. You can also arrange by more than one column. So say we want to first arrange by the carat size. Then we could say diamonds, arrange diamonds with carat and in descending order of price. Then now you'll see that the data frame is first arranged by carat size, again in ascending order, and within each carat size they are ordered in the descending order of price. And of course you can also specify it to arrange in the descending order of carat as well. The next verb is summarize, which is used to aggregate data. And you can think of this as applying a function to an entire column that returns one scalar value. So for example, if you wanted to get the average price of all diamonds, you can do summarize diamonds and say average price equals the mean of price. If you run that, we get this reduced data frame here that only has one entry, and that entry is average price. So that covers all the 5 basic verbs. That's filter, select, mutate, arrange, and summarize. And I started by telling you that these 5 verbs will let you do most of your data manipulating tasks. What about trying to get the average price of diamonds for each cut type? Or maybe finding the largest carat diamond, but in each color category. A natural way to think about this would be, say, for average price of diamonds in each cut type, I'll use the filter to create 5 different data frames, one filtering for each cut type, and then I can use summarize on each of those 5 data frames to compute the mean price for each data frame. Right? That you could do. What about finding the largest carat diamond in each color category? Again, you could use filter to create 7 different data frames, because there are 7 color types, and then use arrange to sort each of those 7 data frames in order of carat size. And then you can use slice again on each of those 7 data frames to get the first row representing the largest carat. And you'll notice a pattern when you start thinking about these tasks, is that you're essentially grouping the data and splitting it into these different categories, and then you're doing some identical operation on each of those splits of data. And this is a well-known pattern known as split, apply, and combine. And this pattern is so common that dplyr has a way to do this in a single command without you having to actually create these n number of different data frames. And that command is known as group by. And what the group by verb does is it simply marks the data frame as being grouped by that certain column that you specified. If I look at the diamonds data frame, then you'll see that this is the original data frame with about 54,000 diamonds inside. Now say I want to investigate by different cut types. So I'll create a diamonds by cut data frame using the group by verb. So it's on the diamonds data frame, I want to group by cut. And if I run that and I look at the diamonds by cut data frame, you'll notice it's an identical data frame. It's exactly the same as the diamonds data frame, except it has this extra piece of information saying that this data frame is grouped by the cut column, and there are 5 categories in that column. When dplyr verbs operate on a group by data frame, then all the verbs or function operate as if they are working on each category. So for example, if I were to use arrange, this will sort the data frame but within each group. Or slice will extract the rows but again within each group. And same with summarize, it'll aggregate values group-wise. And even functions like n, which gives you the number of rows in a data frame, if you use it for a grouped data frame, it'll count the number of rows in each group. For a quick example, now that we have a grouped data frame, this diamonds by cut, if we were to slice diamonds by cut and just take the first row, instead of getting 1 row, we'll get a data frame of 5 rows, and this is 1 row for each cut. Also, we could do summarize on diamonds by cut, and say we want to count the number of diamonds in each cut, then we can set the count to n, and we want to find the average price, so it's the mean of price, and just by running this one row, dplyr will split the data frame into 5 different data frames by the cut type, and it'll apply these 2 operations, namely the count and the mean of price, on those 5 different data frames, and it'll combine them into a single data frame. Now usually when manipulating data, our tasks will involve more than just 1 or 2 verbs. So we'll need to chain multiple operations. For example, say we want to find the proportion of different colors in each cut category. And one way we could find this is to take these 4 operations. First, we can group the data by cut. Then we can use mutate to create a column that will count the number of diamonds in each cut. So that'll give us the denominator for the proportion of colors in each cut. Then we can do another group by on that same data, but this time group by the cut and the color. And now if we use the n function on that new grouped data set, that would count the number of each unique color within each cut. Then we can use the denominator column that we computed from this second step, along with this new grouped by data frame, to compute that proportion of each color within each cut. Now one thing to notice is that dplyr verbs will not modify the original data frame. So what I mean is, even if we do filter diamonds caret equals 3, we'll get this tiny data frame with 8 rows that are only looking at the 3 carat diamonds, but our original diamonds data frame is left untouched. And that's a good thing, because you don't want to make changes to your original data every time you do some kind of operation. But this makes multiple operations on a data frame difficult, because this means every time you want to chain different operations together, you have to somehow save the intermediate results somewhere. So if we go back to that problem that we were looking at, one way to do those 4 steps would be to save every intermediate step. So the first step was to group by cut, so we do by cut, group by cut. So there's one step. Now the second step was to mutate the grouped data frame and add the count, so n. Again, we would have to save this step. Let's call it count cuts. So we run that. The third step is to regroup by cut and color. So it's group by count cuts, and we're going to group it by cut and color this time. And again, we would have to save this result to a new variable, so maybe by cut color. We run that, and finally we can find the proportions by computing summarize on our final data frame of by cut color, and what we want to find was the proportion of n over this large n. Now if you look at the proportions, we have the proportion of each color within each cut. But notice how in this by doing this, we have to save 4 different data frames. This might be a good way to do this computation if somewhere down the line you actually need these intermediate data frames. but more often than not, you don't really need those. The preferred way of dealing with these situations in dplyr is to use the pipe operator. Now this is just an operator that looks like this, with the percent sign and this arrow and another percent sign. Now what it does is it takes whatever is on the left hand side and uses that as the first argument to whatever is on the right hand side. And this works very well with dplyr's verbs, because if you recall, all verbs in dplyr will take a data frame as its first argument and also output a data frame as a result. What this means is that these 4 verbs can actually be tied in to a single pipe. So we start from a data frame and we can pipe this into a verb. Now notice the first verb we want to use is a group by. So we pipe that into a group by. Now the pipe will provide the first argument, so we only need to provide the remaining arguments, in this case cut. And then whatever comes out of this group by cut, now we want to put into mutate. So we do another pipe, and the next verb is mutate, so we do mutate. Again, we can omit the first argument, which is going to be the data frame that comes out as a result of the group by, and we just specify that n is set to the count. You can do another pipe, and you get the general idea. You can, by using this pipe operator, we can just tie multiple operations into this single pipeline of commands, which isn't only more efficient because you're not saving intermediate results, but it's also much easier to read. So now we have this pipe of 4 verbs, and if we run this, as a result, we get this single data frame without ever saving any intermediate results. So in the slides, I've come up with some exercises that I think reflect common use cases of dplyr without going into too much detail of different packages. I won't go through each one of them in this video, but the slides contain the solutions as well, so it should be quite easy to go through the solutions if you want to. And that's it. And remember, this is just the tip of the iceberg. There are a bunch of other really good resources out there if you want to learn, and I'll try to mention some in the video description.